For this video, we want to talk about the analysis of vanillin white chocolate by gas chromatography. Okay, this is our group members, which is start from me. My name is Sidin Shofila binti Muhammad Nasir, and next Nur Aina Manajwa binti Sidi Ahmad, Fatih Nur Najwa binti Shubri, Nur Fatihah binti Muhammad Zahir, and lastly Aisha Zulaika binti Jafri. I will start with the introduction. The first one is gas chromatography is a separation method that uses changes in boiling point or vapor pressure and polarity to separate very complex mixtures. GC was not created until 1952, despite the fact that chromatography was introduced at the turn of the 20th century, and Martin also saw no reason why the mobile phase should not be a gas in their 1941 paper. James and Martin published the first paper demonstrating the use of GC to separate volatile fatty acids in the following year. Gas chromatography, which is commonly known as a gas liquid chromatography (GLC), is a kind of a chromatography that uses a liquid stationary phase and an inner gaseous mobile phase. Compounds that have a greater affinity for the stationary phase spend more time in the column and thus elute later and have a longer retention time (RT) than samples that have a higher affinity for the mobile phase. Besides, affinity for the stationary phase is driven mainly by intermolecular interactions, and the polarity of the stationary phase can be chosen to maximize the interactions and also the separation. Ideal peaks are Gaussian distributions and symmetrical because of the random nature of the underlying interaction with the column.
Now, let's proceed with methodology. Firstly, an internal standard and a saturated solution were added to each vanilla extract in an aluminum flask. Second, after adding the extraction solvent, the solution was placed on a magnetic stirrer. After that, the mixture was separated in a separating funnel so that the organic fraction containing the chemical of interest could be analyzed. Number 3, 100 ml of vanilla extract was placed into a 20 ml vial. As a result, in the headspace of a 20 ml vial filled with vanilla extract, a polydimethylsiloxanes coated twister was put in a twister insert. A cream cap was used to shut the vial. In a heated tray, the vial is heated to 70 degrees Celsius. Number 4, the twister sample was transferred to an empty TDU tube and closed with a transport adapter after 3 hours. Number 5, the BFFAP column was used to isolate the vanilla scene components. Number 6, preheat the oven to 40 degrees Celsius with a temperature gradient to 240 degrees Celsius. Number 7, using a mass spectral library and internal database, the aroma component was identified from the mass spectra. Number 8, the fragrance constitutions of the vanilla extracts were analyzed using a gas chromatograph with a mass selective detector and an olfactometric spot. Number 9, TDU desorptions was used to remove the scene components of vanilla extract from the tested twister when the PTV inlet and TDU were in speedless mode. The TDU temperature has been configured to start at 70 degrees Celsius and gradually grow to 250 degrees Celsius at 60 degrees Celsius each minute. Number 10, a fused silica capillary column was employed to separate the vanilla's fragrance components. Number 11, the vanilla extracts were evaluated in full scan mode using the MS and ODP detectors. Number 12, the effluent was transferred to the ODP3 sniff port through a capillary GC column linked to an uncoated transfer line.
I will continue the part of that analysis. The sensory profile of vanilla extract in white chocolate is based on figure 3. In terms of milk powder, almondy and anistic notes, there are different variants between the three origins of vanilla in white chocolate. The Indonesian sample has a stronger intensity of milk powder, whereas the Papua New Guinea sample had a higher intensity of almondy and anistic notes.
Now, I will continue with the discussion. First thing first, pure vanilla extract were initially examined using gas chromatography mass spectrometry, and then the same extract was studied using the gas chromatography mass spectrometry or spectrometry technique. This method resulted in order description by highly trained sensory scientists. The amount of vanillin in all three extracts was identical. However, the sensory evaluation revealed that the Indonesian extract has less powdery vanilla than the others. Powdery vanilla is enhanced by anisile alcohol, which is found in Papua New Guinea extract. In Papua New Guinea, phenolic compounds were discovered. Following data analysis of the vanilla extract using GCMSO, glycol and vanillin were found to have the maximum odor intensity for all three origins. Both aroma compounds are phenolic in nature. In all three vanilla origins of Madagascar, Indonesia, and Papua New Guinea, glycol and vanillin are significant fragrance components. The three panelists concluded that the Indonesia vanilla extracts, which is ethyl 2-methylbutanoic and 3,2-methylbutanoic acid, had 3 times the odor intensity of the other two extracts. These aroma compounds, which are associated to fruity and fermented notes, are the main aroma compounds in Indonesia vanilla, along with glycol and vanillin. As the result indicates, there is clear relationship between sensory characteristics of three different origins of pure vanilla extract and their sensory characteristics in white chocolate. Based on the observation, the simpler the chocolate base is, the stronger the relationship. Hereby, glycol and vanillin were the main key aroma compounds and were related to phenolic notes. These characteristics were detected in white chocolate by trained panel. The panel discovered the white chocolate has a more intense milk powder attribute than Indonesian vanilla extract.
The last part for this experiment is conclusion. To sum up, the main objective for this experiment has been successfully achieved, which is to analyze the vanillin in white chocolate by gas chromatography method. From the results shown, some different odors such as fruity, buttery, fermented, floral, phenolic, and spicy also have been obtained and been classified for different odor groups of vanilla extract. From this experiment, the method that have been used, which is the gas chromatography paired with mass spectrometry in combination with olfactometry, has shown the great correlation result with the sensory characteristics for both vanilla extracts and chocolate samples. It can be proved when during the analysis, glycol and vanillin were indicated having the highest odor intensity for all the samples. These two aroma compounds can be classified as phenolic. This gas chromatography method is highly suggested to use for this research because it offers a very good sensitivity, resolution, and separation ability, and it is cost efficient, which practically everyone can do it. Other than that, based on this study, we also know that white chocolate is a sample that is easy to detect the compound or odor in it, and it can be proved that it contains a higher vanilla perception compared to other chocolates. And the main cause of it is because the amount of cocoa solid in it are not as much as dark chocolate or milk chocolate. Assalamualaikum warahmatullahi wabarakatuh. My name is Aisha Zulaika, and my group and I will proceed with the experiment 6, which is high-performance liquid chromatography for the experiment of determination of vanillin from the vanilla extract. I will start with the introduction. What is HPLC? HPLC, or high-performance liquid chromatography, is an analytical technique that was used to separate, identify, or quantify each component in a mixture. The mixture is separated using the basic principle of column chromatography and then identified and quantified by spectroscopy. HPLC is basically a highly improved form of column liquid chromatography, which instead of a solvent being allowed to drip through a column under gravity, it is forced through under high pressure that up to 400 atmospheres. The instrument that was used in this procedure including pump, injector, column, detector, and mobile phase reservoir. All the software and HPLC data system also needed as well. For the principle of high-performance liquid chromatography, the first step is the purification takes place in a separation column between a stationary and a mobile phase. What is stationary and mobile phase? The stationary phase is a granular material with a very small porous particles in a separation column, while the mobile phase, on the other hand, is a solvent or solvent mixture which is forced at high pressure through the separation column. After that, by using a valve with a connected sample loop, such as a small tube or a capillary made of stainless steel, the sample is injected into the mobile phase that flow from the pump to the separation column using a syringe. Subsequently, the individual components of the sample migrate through the column at different rates because they are retained to a varying degree by interactions with the stationary phase. After leaving the column, the individual substances are detected by a suitable detector and passed on as a signal to the HPLC software on the computer. At the end of this operation, a chromatography in the HPLC software on the computer is obtained. The chromatography allows the identification and the quantification of the different substances. Moving on to vanillin. What is vanillin? It is a pure ingredient and a primary component in a vanilla extract. The extraction usually comes from vanilla bean or vanilla pod. Generally, vanillin is a member of the class of benzaldehydes carrying a methoxy and hydroxy substituents at a positions 3 and 4 respectively. It has a role as a plant metabolite, an anti-inflammatory agent, a flavoring agent, an antioxidant, and also an anticonvulsant. In this experiment, the method is focusing on the analyzation of the wild vanilla pompona SSP grandiflora fruits from the Peruvian Amazon, and the quantification process was being done by high-performance liquid chromatography paired with a diode array detection, HPLC DAD.
Next, I will continue the part of methodology. The first part of methodology is vanilla sample preparation. The first one is individual lyophilized fruits were ground to a fine powder using an electric grinder. Secondly, 2 grams of the ground material was chocolate extracted with 48% aqueous 200 ml ATOH for 24 hours. Then, the ethanol was removed by vacuum evaporation and the aqueous turbid solution was taken to 50 ml in a volumetric flask. Then, hydrolysis of the glucosides was achieved by incubating 10 ml of the extract with 150 ml of viscoenzyme and 300 ml of cellulose at 45 degrees Celsius for 8 hours. Then, 4.5 ml ethanol was added and the process continued for 1 hour to yield the hydrolyzed fractions. Next, the non-hydrolyzed portion followed the same procedures except for the enzyme addition. Next, the volume of both sample was adjusted to 15 ml prior to HPLC analysis. Then the experiment was performed in duplicate. Then the vanilla extract was passed through a 25 mm PTFE 0.45 mm syringe filter prior to injection into the HPLC system. And the last one is each extract was evaluated in triplety. The second part of method is HPLC analysis. First one is the sample was analyzed on an Angeline 1200 series. Second one is the column was used was a chromolith and the mobile phase a mixture of 2 solvents which is E and B. The number 3 is elution was achieved at 30 degrees Celsius with a gradient of 3 to 7% B in 2 minutes. Then the compound were monitored at 200 nanometer for GB vanillin and alcohols 2, 4, and 7, while 254 nanometer for vanillic acid and 4-hydroxybenzoic acid and 280 nanometer for 4-hydroxybenzaldehyde. Then number 5 is the injection volume was 10 ml and all samples were filtered through a PTFE 0.45 mm syringe filter prior to analysis. Then the LCE ESIMS experiment were performed on Bruker Daltonics Esquire 6000 controlled by Compass 1.34 SQ HCT software. Number 7 is the HPLC system was described for the HPLC DEC. Number 8, the gradient separation was carried out at 35 degrees Celsius using a volatile mobile phase composed of solvent A and B, which is MeOH, following the same gradient as above but at a flow rate of 1 ml per minute. Number 9, after reaching 19% B is what held isothermal rate for 16 minutes, the injection volume was 7 ml. Number 10, the semi-preparative HPLC purification was conducted with a chromolith RP 18 electron using a condition established for the LC-ESIMS run. Final one is fraction collection was guided by retention time and UV spectra of the evaluate. The last one is the method validation. Firstly, the HPLC method was validated according to ICH requirements. Next, the external calibration curve were prepared with solution containing compound 1 to 7 in concentration between 0.167 and 992.8 Lg per ml. In the case of GV, the range was 0.864 until 1035 Lg per ml. The linearity was checked by regression analysis of at least 6 concentrations of each compound. Next, repeatability was confirmed by performing injection on the same day at the given concentration of each compound. The number 5 is the immediate precision was calculated over 5 different days, interday at an established concentration per substance. The number 6 is highly diluted solution of each compound were used to achieve signal to noise ratio of 3 and 10. Number 7 is the recovery of the complete analytical protocol was evaluated by the enrichment of vanilla samples 2 grams with 50 mg of compound 1, 4, and 7 and 10 mg of 2, 3, 5, and 6. Number 8 is the recovery was expressed as the percentage of the total amount recovered. And the final one is the process was repeated in triplicate.
Now, I will continue with the result. This is a qualitative result. Graph shows the average humidity of 3.5 to 9-month-old intact V. pomponal grandiflora fruits. The observed rise in dry wick through fruit development has previously been noted with V. planifolia fruits. The length and width of the 24 fruits used to calculate humidity range from 10 to 25 cm and 2 to 4 cm respectively. This is a quantitative result. Precision was addressed using intraday and interday repeated analysis at 4 different doses per drug, retention duration, and peak area. The results were generally good, with coefficients of variation CV of less than 2% for each standard concentration as indicated in Table 3.
We will continue with the discussion. The alcohols were identified using the ion 20+, whereas the others displayed the hydrogen plus signal. The presence of the ions potassium plus, sodium plus, and also 1 to 6 plus, which have MZ 353, 337, and 153 respectively, will establish the structure of GV. Next, the letter ion fragment indicates the glucose loss. The HPLC quantitative study was performed on green and damaged fruits at 7 different stages of maturation. The quantities of GV, free and total glycons 1 to 7 were determined based on the quantity present in enzyme-treated and non-treated extracts. The appearance of 4-hydroxybenzyl, 4-hydroxybenzoic acid, and N-acyl alcohol as glucosides throughout food maturation was clear, determined by the ratio of free total glycon, For all the other compounds, the glucoside form begins to terminate near the end of maturation. The most frequent component in 3.5-month-old V-SPP granitiflora fruits was 4-hydroxybenzyl alcohol. Over the time, the concentration will decrease as the number of additional vanillin compounds will also increase. Vanillin compounds 2 and 3 have been found in a greater concentration than benzyl derivative 5 and 6. Next, vanillin production is slightly slower, which is 20 more gram per month in V-SPP granitiflora fruits from over 3.5 to 8 months period, then in V. planifolia fruits, which is 68 more gram per month according to the certain group. Throughout the 9 months, the content of vanillin in V-SPP granitiflora fruits will increase significantly from 100 to 375 more gram dry.
In conclusion, high-performance liquid chromatography required array detection method was used to detect the 1 to 6 compounds in the presence of GV and N-acyl alcohol in developing fruits of V. SSP grandiflora from the Peruvian Amazon. The obtained precision, recovery, linearity, and sensitivity values showed that the method is suitable for quantification. Glycons and glucosides were present during all of the developmental stage after pollination, and an important fact for an improved understanding of the biostatic pathway of vanillin is developing fruits. As a whole, the chemical profile of white uncured fruits of V. SSP grandiflora is markedly different from those of other two commercial vanilla species, specifically in the simultaneous high content of vanillin, which is 4-hydrobenzyl alcohol and N-acyl alcohol. I think that's all from us. Thank you for lending your ears and hope this presentation can give you all new knowledge. Thank you.